All right, let's dive right into this explainer. Today we're doing something absolutely incredible. We're going to assemble a highly specialized crew of AI models to conquer one of the most chaotic, nonlinear, and honestly downright stubborn systems on Earth, the weather. We're not just going to casually ask a single AI if we need an umbrella tomorrow. No, we are going to build a temporal weather machine.
So here's the core problem we face. For centuries, humans have relied on historical patterns to predict the weather, right? But today, those traditional weather models are becoming incredibly fragile because the historical baselines they rely on are rapidly shifting. I mean, how do you predict the future when the past is no longer a reliable guide? When ancient stable climate cycles literally collide with the wild, nonlinear chaos of a warming planet? To figure this out, we need a totally new approach to intelligence.
Here's our blueprint for today's explainer. How we're going to stack these specialized AI systems together. 1. The predictive limit. 2. The parliament of perspectives. 3. Ancient metaphors and heuristics. 4. Real-time empirical physics. 5. The adversarial override. And 6. The temporal weather machine. Let's get into it.
Section 2. The parliament of perspectives. To actually solve the predictive limit of weather forecasting, we've got to stop treating AI models like they're in some sort of gladiator dominance contest. Instead, we need to build a cooperative assembly of intelligence. The big takeaway here is that no single algorithmic framework contains the entire terrain of reality. Our foundational principle relies on what the source material calls cognitive geometry. Think of it like this. A telescope and a microscope both look at reality, right? But they reveal completely different structures while totally hiding others. So we need different cognitive geometries working together. This is a practice called cooperative routing intelligence, ensuring that the blind spots in one model are perfectly covered by the strengths of another.
And man, this brilliantly illustrates our AI heist crew. In this Phase 2 routing matrix, every single AI model gets a highly specific role based on its audited cognitive strengths to crack the code of hyper-accurate forecasting. History AI? That's our empirical historian, anchored in sequence prediction. Command R+ handles the micro-retrieval of localized sensor data. Then we have Gemini Weather Next as our structural synthesizer, crunching the complex fluid dynamics. And finally, DeepSeek acts as our adversarial critic, relentlessly applying skeptical stress testing to the group's assumptions. It's like the ultimate team-up.
Section 3. Ancient metaphors and heuristics.
All right, let's meet the first piece of our machine, the historian. History AI looks at the deep past to establish the behavioral shape of regional weather, and it reveals something pretty profound. It tells us that ancient concepts, like the Farmer's Almanac and stories of the Great Flood, well, they aren't just magic or myths. Actually, they are early low-fidelity statistical models. Long before we had silicon computers, agricultural societies used generations of human observation to map out biological and meteorological sequences. The Great Flood, for instance, serves as a deeply historical metaphor for the catastrophic loss of environmental slack.
But okay, here's the major friction point. Yes, History AI knows those cyclical patterns brilliantly. It's got those centuries-long baselines recorded in the almanac down cold. But modern climate change, it breaks historical baselines. The past alone just isn't enough to predict the future when the fundamental temperatures of the globe are shifting under our feet. So to make the almanac actually useful today, we have to triangulate it against something else entirely, which brings us to the next vital components of our machine.
Section 4. Real-time empirical physics.
To ground those ancient metaphors in the present day, we've got to leave the realm of history and step straight into the realm of hard physics. Enter Command R+. This model acts as our ground-level scout, because let's face it, historical patterns are utterly useless if your immediate environment has drastically shifted. So Command R+ pulls in exact real-time sensor telemetry. We're talking localized barometric pressure drops, real-time wind resistance, current humidity, and live PM 2.5 air pollution levels. This data acts as the strict, unyielding physical boundaries for our calculation. No guessworks allowed.
Now we bring in Gemini Weather Next, our structural synthesizer. This is where it gets really cool. It sits right between History AI's macro-cyclical patterns and Command R+'s real-time telemetry. Let's say History AI flags that the almanac predicts a hard, freezing winter, right? And Command R+ confirms an unseasonal barometric drop happening right now. Gemini Weather Next takes those exact variables and processes them against strict physical laws of homeostasis and the Penman-Monteith equation. Basically, it translates the ancient metaphor directly into rigorous math.
This flow you're seeing is absolutely key to the entire system. It represents the rigid epistemic hierarchy matrix. It's how we structurally stack these AI systems so they don't just, hallucinate data. It always starts at level 1 with ground truth, that empirical sensor telemetry. Then it moves up to level 2 specialization with hyper-localized physics, up to level 3 generalization, and finally level 4 synthesis, where language models give us a conceptual output. By forcing the data to travel up this specific hierarchy, our probabilistic language models are permanently chained to hard, localized physics.
Section 5. The adversarial override. But what happens when things go wrong? Like what happens when the cyclical patterns of the almanac clash catastrophically with the nonlinear realities of modern climate shifts? This is where DeepSeek enters as our adversarial critic. I absolutely love this quote from the source. We use history as a guide, but physics as the law. DeepSeek's entire job is to enforce a hard boundary. It ensures that mathematical fluid dynamics and real-time telemetry must always override the historical metaphor when the facts diverge.
So, why is this adversarial role so absolutely crucial? Well, look at this number, 1.2 degrees Celsius. DeepSeek actively prevents what the source material calls precedent overfitting. It recognizes that we simply cannot blindly trust the Farmer's Almanac's cyclical predictions when global baseline temperatures have already risen by 1.2 degrees. If we just blindly followed the historical pattern, the model would fail catastrophically in the face of modern climate change. DeepSeek basically cuts off the nostalgia and forces the whole machine back to empirical reality.
Section 6. The temporal weather machine.
By successfully synthesizing the past and the present through integrators like ChatGPT and Copilot, the temporal weather machine actually comes alive. We've effectively triangulated historical heuristics, like the Farmer's Almanac and the Great Flood, with real-time empirical telemetry and Gemini WeatherNext thermodynamic physics. But to remain scientifically honest, our system must explicitly flag its uncertainty zones. This is a mandatory part of the protocol. Our machine openly acknowledges that it still has blind spots. For instance, the almanac is regional, but real-time telemetry can be massively distorted by hyper-localized geographic anomalies, like urban heat islands or specific mountain ranges. Plus, we don't yet know the exact mathematical discount rate to apply to those historical almanac predictions to perfectly account for modern nonlinear climate shifts. Acknowledging exactly what we don't know is what makes the whole system trustworthy.
I want to leave you with this provocative thought. We just triangulated ancient agricultural wisdom with cutting-edge thermodynamic physics to map the chaotic atmosphere. But the real game changer here isn't just the weather prediction, it's the method. If we stop treating AI models as isolated, competing chatbots and start assembling them as complementary cognitive instruments in a true parliament of perspectives, what other impossible problems could we solve together? The boundaries of what we can understand become truly limitless. Thanks for joining me on this explainer. I hope you found this as fascinating as I did.